Hello folks, welcome to another uber boring and long video relating to the Tesla Model 3 logic board project. This video is going to be primarily aimed at the folks who are participating in the beta program, where I've sold 5 of these boards to people who are going to foolishly decide to fit them in their drive units and see what kind of feedback that we can generate, find problems, iron them out, and so on before general release. So it's specifically going to relate to the V3 logic board, but there'll be a lot of the fitting and so on info that'll be in this video that will apply then to future versions of the board. So what I would ask is that if you want to know why I'm pursuing this particular project or why I'm going down this route for running the Model 3 drive units, please don't pepper the comments with questions on that. There's lots of other videos in the series where I detail the reasoning behind this. So without further ado, let's get started on what we're going to be doing here. So when you receive the board, unless otherwise informed, it will be loaded with the STM32 FOC firmware suitable for use on the rear drive units, which are the permanent magnet motor. If you wish to use it with a front drive unit, please let me know and I will load on STM32 sign, and you can then use that with the induction motor in the front drive unit. Also loaded onto the processor will be the parameters that I have used here during bench testing. So things like the sync, offset, and throttle ramps and all that kind of thing will be in there. One part of the beta program that I'm quite interested in seeing is I have found with the 2 rear drive units that I have here, one on the bench and one in the car, a sync offset value of 2200 seems to run both of them perfectly fine. So I'm interested to see if the beta testers that are running with rear drive units, if that value of sync offset will work for you. If so, it would be very useful, because it would mean that then once we get a value that's doing what we need it to do, future users of the board then wouldn't actually have to do tuning. It'd be pretty much, as they love to say, plug and play to a point. So that's where we stand. So on the beta version of the board, there are some components that we have to fit. They'll be supplied in a little bag with the board. So I will go ahead and just detail the fitting of those components here, and then we will get into the removal of the OEM logic board from a rear drive unit inverter, the removal of the components from that board that we then need to translate onto this one, and finally then fitting that logic board back into that rear drive unit inverter, and then we'll get it on the bench and see if we can make a motor spin. Okay, so the first components that you'll have to fit are 2 little opto isolators. They are ACPL M49T-000E, and they are in positions on the board U5, which is up here in the top right hand corner. I guess this would be, I don't know if it's really Chicago. I think Chicago's around here. So I'm not sure what's up in the top right hand corner of America. My geography isn't that good. So U5 is up here, and U33, of course it is down here, probably around the Chicago area. So we're going to go ahead and fit those. Now, in order to do that, the way that I like to do it is get a little bit of flux on here. This is the flux that I use. It's just AliExpress stuff. It is Kingbo RMA 218. So when I'm doing any little SOIC parts like this, it's only a hint of it that you want to put on the pads, like so. So we will get our optocouplers out and we will get them on here. Okay, so you should get 2 of these in your kit. Now, for those of you watching out of general interest, what I am hoping to get to is for the release boards, you won't have to be doing this kind of thing, so there won't be like bits that can be fitted that aren't fitted. So the usual orientation, your little dot on the chip lines up with the line above the pad on our PCB. So I'm just gonna get him roughly in position, and I'll do this in real time with you folks here, just so you can see what's involved. And just tack one pad down like that on one corner, then work up on the far corner. And again, that little bit of flux just goes a long way. I do have a little computer fan just rigged up here on the bench just to take the fumes away, because otherwise you would be listening to me coughing and spluttering and having all manner of a bad day. For those of you interested, U33 here actually controls this resistor bank. It controls turning on and off that resistor bank, what I guess these days they call the active discharge system. So that actually works, by the way. I know, amazing, something on this board that works. Now at the minute it's just turned off by the STM32, but I think Dave is probably going to work some of his magic and have a logic behind turning that resistor bank on and off. And yes, I have tested it at full HV. It does get hot, but after about 3 minutes it didn't melt. So yeah, and that's without heat sinking, by the way, because as we'll see later in the video, there is a thermal pad that sits over this part of the board there we go, that transfers heat from this to the, I guess, to the water jacket really in the drive unit, or at least to the into the, what am I talking about here, into the heat, the you know what I mean, the casing of the drive unit. So those are our 2 little optocouplers fitted. Now we next, again this is particular to the beta boards, but we've these 6 output transistors here that we have to fit. Alrighty, so I'll just put a little bit of flux on the pads here. I'll do 1 or 2 of these and then I'll disappear and get the rest of them done off camera for you. They're pretty straightforward. So the tip I would just give folks is to, again, You can use a slightly heavier solder for this. I'm just going to tack down one of the leads here. Hope you can see this with my silly head in the way. We'll see some of it anyway. And just tack down the two leads. Then you need to get on the big tab on the transistor on the back, get some heat into it. And you need to kind of let the solder, there it goes. And a capillary action will pull the solder in underneath that guy then. There we go. And just press down on your pads. And I'll go ahead and get the rest of these transistors. Alrighty, so we're just on our last transistor fitting here now. And there we go. Now, one thing is worth noting is that the condition you see the board in now is where I would like to be having the release boards when they go on general sale. So you won't have to fit any of these kind of parts. The only parts that you would need to surface mount solder will be the 6 gate driver chips and the gate driver transformer. So our board is now reasonably prepped to the point that we can get the drive unit inverter on the bench here. So we can take this board out of the way. We can get the drive unit inverter on here and start looking at removing the OEM PCB. Okay, so we've got our inverter here on the bench now. So the first thing that we're going to want to do, just for convenience, is to remove this little gasket. It locates on these two pins here. So we'll just take this guy off and pop him over here out of the way. Now there's two size of Torx fastener that we have to remove. There's a larger one, actually the board mounting screws, and then there's 3 smaller ones for mounting the current sensor block on. So we will go ahead and spin out those fasteners. Of course, I can't tell you what size they are because the number has worn off my silly screwdriver. So that'll be another job for one of the beta testers to tell us what size the Torx fasteners are. So there's 1, 2, 3, 4, 5, 6, 7, 8, and 9 around the periphery of the board. It figures it would be divisible by 3. Then there should be 2 here in the center of the board. And then while we're here, just for convenience, we'll take the 3 fasteners out of the current sensor block, which again are smaller torques, and I can't tell you what size that is either because the numbers have worn off this one. Oh wait, hang on, I can. T10. They're a T10. And 3. And that's the easy bit, folks. Now, folks, this is the part that we absolutely dread, the desoldering. It's especially difficult here because we are dealing with plated through hole multi-layer board and lead-free solder, of course. So I'll show you what I do, which will probably not work at all because we're now filming it. In terms of the tools, flux is your friend. I have one of these desolder gun things. It's probably, as Homer Simpson would say, the cause and the solution to all of my desoldering problems. It's the cause of them because this thing gets jammed up and doesn't work, and I end up having to take it apart and either rod it out with a piece of MIG wire or blow it out with compressed air. It's the solution because when it does work, it works very well. But it's a cheap one, so it doesn't put as much heat into the job as it should, again, specifically for a board like this. So I tend to use both the desoldering gun and my soldering iron together. If you do not feel comfortable doing this part, my advice to you would be to seek out a friend, maybe a maker group or a repair shop or someone that has some experience doing this kind of thing, because if you're going to damage something, this is the point where you're going to damage something. So with that being said, it's not impossible, but a bit of care and attention and taking your time at it is pretty much critical. So we'll start with these 4 HV positive connections here just to get ourselves warmed up, no pun intended. So I'm going to give them a dose of the old King Bow. Not going to go crazy, but just enough that they'll flow that bit easier. And just because of my eyesight and that, I am going to be using my little magnifier thing here. So if you see that, if you see me going around like that, you'll know that it's just me. So start with this guy here. What I tend to do, take my soldering iron, take my old friend here, come in here and get that solder warm. And you'll see the amount of time that it's taking just to get that solder flowing. Then you can move the pin. Once the pin starts to move, bring this guy in and wiggle him. And you saw there just towards the end that this actually stuck on the pin. Simply because it wasn't able to keep the heat in there because the PCB and the pad were actually sucking that heat away. Now, it has actually done quite a good job, and this pin is now free. I can kind of touch it. The way to know is take a little tweezers or a little screwdriver or something and see if you can wiggle the pin, and indeed I can. That pin is now free in there. So let's try the same procedure across these 4 guys here and see how we get on, and see if one of the many cleaning incidents then that I have to do. So again, I'm bringing the soldering iron in and the solder molten until the pin moves. Then I'm wiggling this guy a bit. More heat in there and I'm off. And I'm just going to see if the pin is free, and it is. So again, I'm going to take my little tweezers. Now that pin, yep, that one's free. And that one's free. So all 4 of those pins are now free. So the next one that we're going to need to desolder, going to turn the inverter around this way so that the high voltage connector is facing me here. And it is these 2 pins, so the 2, if you will, the pins nearest me and the pins further from me that we have to desolder here from the HV connector. So again, we'll give them a little blob of flux and we'll employ the same procedure. Now, can you just go in there with this, heat it and vacuum it? Sometimes. I find that this procedure where we heat first, then bring in the gun, gives the better solution. At least based on the hardware that I have. So now I've got my pin moving. And I'm going to get him. And we'll have a go with his friend here on the back. No, I didn't get out hot enough. Now I did. Now. And again, same procedure. Little tweezers or something like that. And just, okay, that one is free. That one's free. That one is still fighting me yet. That one there has got a little blob on him there still. So what we're going to do is bring in a little bit more flux. And I'll try him here just with the gun, but yeah, I don't think so. And the reason for that is that there's a particularly thick pad and track here that comes off this pin. So again, don't panic or don't go just going crazy at it if that occurs. We put a little bit more flux on there. And just see how much heat that's taking to flow. There we go. Now we're moving. That's it. That one's free and that one's free. Now the key thing again, just to recall here, is that the one thing that we need to be 100% sure of is that we go around each pin with a little tweezers or something and make sure that they're free before we try to lift the PCB. And that's going to be particularly important here because we're now getting into the meat and potatoes, which is our power transistors here, and we need to desolder those guys. Now this inverter here is one that only has, it's the same as the one that I have in the car. Don't ask me the number, it'll be like 900 and something, 960, 970, something like that. But it's only got 3 transistors per high and low. So in the case of the B phase here, which is nearest me, the first one is not populated, so there's no need to desolder that. But if you have one of the inverters where there's 4 transistors per high and low side on each phase, then you will need to desolder all of them. But I'm kind of lucky I don't need to do these guys here. So I'll do a few and I'll cut the video, and then we'll come back when we're ready to lift the PCB off. Okay, so I'm going to start here just on phase B, and I'm going to just do little blobs of flux on them. This is the low side and the high side. There's a few things in our favor on the transistors, folks. And that is that they don't have big, heavy pads or connections to planes in there. They've just got their relevant connection tracks. So, again, get my soldering iron in one hand, desoldering gun in the other. I'm going to come in and I'm going to heat the pad first of all. Then I'm going to move up until I've got the pin moving. Bring them in. Keep the soldering iron there as well. And there we go. I'm going to do the next one. I'm going to get my little tweezers. And they are not moving, but that can sometimes happen because they just get, you can give them a little pop with the soldering iron. And that sometimes works, but they'll tend to stick. So what you can do is pop them with soldering iron, then grab them. And try and keep them moving while you desolder, while you just heat up the solder. So I'm doing the same again here now. I'm just keeping the pin moving, and then, yeah. So there we have now our first transistor desoldered here. I'll go for one of the high side guys here. Go after one of those. I'm gonna just heat that up much as I can. I'm in. I'm melting that, and it didn't quite get it all. So I'm going to try and go again. Yeah, we didn't win that one. So basically now on this one, what we got is that the solder went cold as it was been drawn up. That's a common thing that'll happen, because keep in mind that they're soldered on both sides. The pads are soldered on the rear as well. So we're going to get a little bit more flux. There we go. Then heat up again. And just keep it moving. Yeah, this one we kind of got. There we go. There we go. And again, if we get to the point where he's not moving, the little pin that's coming up isn't moving free, we'll just knock him loose with the soldering iron, grab him with the tweezers, and keep them in the middle until the solder cools off. And again, same procedure here. Yeah, so we've now got two transistors perfectly desoldered there. So I'll cut the video here because it's going to be a rinse and repeat right the way down until we get all of these little transistor legs to the point that we can get our tweezers and just give them a little shake and check that each one is free from the relevant pads. Okay folks, we've got all of our transistors desoldered now. I find once you kind of get a bit of a rhythm going with the heating and you're pulling the solder out, it goes pretty well. So I had to stop twice to blow out blockages in that desolder gun, but other than that, we're pretty good. So last thing we need to do now up here on our 30-way connector is there's this little kind of a clip dude that we have to pop out. And he's gonna probably try and fight me because we're on camera, but I should be able to get him just by pulling him in one direction and getting a little thing at a... Oh, yeah, it's gonna fight me because we're on camera. Of course it is. Right, yes. Let's get some professionalism here, please, Damien. Okay, sledgehammer. Normally these guys pop out pretty easy. I wasn't even thinking about it. I was thinking, oh yeah, this will be handy. No one's going to think I'm a butcher now. Ah, there we go. Finally. Okay, there's our little clip. I'm going to keep that. I'm putting that back in. So the board should begin to lift, but keep in mind that although all of our pins are free, some of them might snag when we go to lift the board. So we're going to keep a good eye out for that. So we're going to start to just rock it. We should be able to see our pins. Now I spotted one there that didn't seem to be too keen on moving, but we're moving here, and we're moving here. We're moving here. So we are in a good spot, I believe, to lift. Let me just check something here. Oh, we've got a hold out. Yeah, we've got a hold out here. I knew I felt something. Again, this is why, you know, even when you think you're done, you might not be. Yeah, there was this one. Hadn't released. So I'm going to release that one and give him a wiggle. And his friend beside him was the same. There we go. He's wiggling, wiggling, wiggling. Yeah, so it's nearly always one or two pins are going to try and catch us out. But yeah, we're up. And we have to come off. This dowel up here is particularly tight. And ta-da! There we go, folks. One OEM logic board removed. You'll notice on the back we've got this little kind of a shielding thing, and it's got these little plastic clips in it. So we are going to remove that from the board and put it on our one before we put it back in. But that is the inside of the inverter. Okay folks, so before we dive into this, let's ask ourselves the question, what do we actually need to remove from this board and what can we buy? So let's start with the minimum things that we need to remove that we cannot buy as yet anyway. So the first one is this header here for the main connector. I've not been able to find a source for that, so that has to be removed from the OEM board. Secondly is this physical block for the current sensors here, so with the ferrite rings and the kind of retaining parts of it in there. The rest of it that you're going to see me remove from here now can be purchased, such as the 6 gate driver chips and the TDK gate driver transformer. And I'll put links to Mauser and part numbers for those in the video description. So if you decide to purchase those, you won't have to remove the transformer or the 6 gate drivers. Now, I'm a cheapskate, so I'm going to remove the transformer and the 6 gate driver chips. I'm going to remove the current sensor block. I'm going to remove the current sensors themselves. Now you can buy those current sensors. I'll put the parts and part numbers and so on in the video description. And then I will finally remove the multi-way connector header here. So before we start on that, we're going to remove this little I guess you call it insulator board here from the back, and it's got these little, I guess, plastic tab kind of things on there. So I tend to make a fool of myself on video, so just pop them up like so with a little pliers, wire cutters kind of a thing. And we'll put those in the bag then, where we have our fasteners that we removed earlier. You know, I can say they're not the easiest things in the world to remove, as Elon has just demonstrated. Thank you, Elon. No problem, Damien, he said. Yeah, come on. Yeah, that one didn't make it. There we go, that one did. Oh no, it didn't. Oh, it did. Alright, so as long as we can get a few, we should be good anyway. There we go. Oh no, that one failed as well. Then we've our little board off. Look at that. Amazing. Okay, so let's pop that over here. And I'm going to get right into, let's start with the gate driver transformer. Now, in order to remove the transformer and the 6 gate driver chips, I am going to be using a small flat blade screwdriver, a hot air gun, and our old friend, the flux, if I can find him. Here he is. So I'm going to put a little bit of flux around, again, no need to go mad. Little bit of flux around the pins on the transformer, like so. Hit my heat gun, and I'm going to put screwdriver just with the weight of the handle just underneath one corner of the transformer, and I get my heat gun, let it warm up. This is a, what is it, a quick 8610A heat gun. It's a pretty good one. I did splurge on it. You can do it with a much cheaper one as well, but just the more heat that you can get into it, the better. So that's going to be a kind of a feature here, folks, that when it comes to desoldering things, whether it's surface mount or through hole or whatever, the key thing to do is to get heat in quick, get the part away, and get the heat off, basically. Now we're also fighting, in this case here, the musk goo. Now the heat, I have found heat is the best way to deal with the musk goo as well. So I'm putting a very small bit of heat, or sorry, very small bit of pressure, quite a lot of heat on here. And I've lost my screwdriver point. There I am. There we go, and I've got this one to pop off here. And I'm just going to keep heating this side of the transformer. And I'm up there. Now I'm going to keep this side lifted just a little while. Now I can let it go down. Oh, here's this idiot with his fancy tune. There we go. One gate drive transformer. Ow. Bit warm. But none the worse for the wear. Now, I'll do one of these gate driver chips with you on camera here. And then I'll do the rest of them off camera. Again, keep in mind you can buy these, so you don't need to do what I'm doing, but if you want to, then stick around. So I'm going to need a little blade, like a little scalpel blade, because what I want to do is to just have something underneath the body of the device and the board that I can put a little bit of pressure on it. Now, keeping in mind as well, we are fighting against a multi-layer board with lots of thermal mass in it. So they're not just going to fly off the thing like you'll see in certain, you know, in kind of simpler boards like 2-layer or even 4-layer stuff. And I'm just putting the very tip of it in underneath the device. Here we go, and you'll see a little puff like that, and then we're going to be able to lift them off like that. So we're not straining anything, causing ourselves any problems. So I'll go ahead and get the rest of them off, and then we will return. Folks, there we go, literally smouldering as we speak. We have our gate driver transformer and our gate driver chips harvested, complete with a little bit of musk goo even from the original logic board. So one thing to note, there's no order for these chips. You can take them off in any order and put them back on in any order. So these components here that you see, so just to repeat, the gate driver chips and the transformer can be purchased from Mouser Electronics. So you don't need to do any of this if you don't wish to. Now, let's get to the bits that you do actually need to do. So next thing we need to do is to remove the current sensor block. We did remove the 3 screws earlier, so now there's these little clips in the middle here. So I'm just going to push them in, squeeze them together, sorry. I'm going to squeeze them together and start pushing down on the current sensor block. And current sensor block should begin to move. Did I forget a screw or something? No, I don't think so. No. Got my little dowels there. Now the current sensors are held in a little bit of goo in here, but that shouldn't be a problem for us. So what I'm going to do is just insert a little bit of screwdriver action there, just to help that a bit. Because certainly, there we go. Now it's beginning to release. Let me get a little bit of assistance on it here as well. I think it is anyway, either that or I'm causing all kinds of problems. Because I did, yeah, that's weird, I don't recall. I could of course pretend that I know what I'm doing here, but I won't do that. Okay, well for some reason, the other one that I'd removed, I had tried to desolder these with hot air, but it didn't quite work out for me. So let's try, just for fun, desoldering them with the soldering iron. So, to do that, I need to turn the flipping soldering iron back on. And we will get our little magnifier. And let me get in here and just make sure I'm not missing something, because we're on camera, it's very possible to miss things. things get missed a lot more on camera. So what I'm going to do is I'm going to actually put the screwdriver in here. I'm going to try and pinch in the guys here a bit. And just, yeah, get our screwdriver in there a little more. Like that. And let's see now if we warm things up on this sensor here. If there's any strain on them. I don't think there is, not by the feel of them. There shouldn't be, because they're only very lightly potted into the thing, so I'm not sure what's going on there. But there's actually a little bit of leaded solder on this anyway, so it's probably no harm to warm them up this way. There we go. There doesn't seem to be any kind of stress on the pins, so that's good. Let me just make sure I haven't missed something really obvious on here, because as far as I know, it was 3 fasteners. 3, of course. Ah, there we go. There we go. There it is. Guess I just wasn't pushing enough. Sorry, Elon, sir. There we go. Now, there's our current sensor block. Removed. Now, can you buy the current sensors? Absolutely. Am I going to buy the current sensors? Hell no. So, we're going to remove them. To remove them, going to use soldering iron. Our old friend, the flux. Flux is our friend in this job, folks. And we're going to use the tweezers. And what we're going to do, I'm going to get the tweezers just around the legs, not fully touching them, but just against them. And then I'm going to heat up I'm going to gas myself because I haven't turned the fan on because I'm a fool. Yeah. Okay, change of plan on that one, folks. We are going to go back to the hot air. And again, this is what I keep saying, that when it comes to desoldering, not just on this job, but on lots of different jobs, the trick is get a lot of heat in fast, get the part out, get the heat off. So you saw me there with the soldering iron. I'm sticking it in there and I'm trying to wiggle it and getting it to do something. That's a surefire way to break something or to rip off a pad or to have a whole pile of regret. So instead, we're going to warm Elon up here with our heat gun. I'm keeping the legs of the current sensor between the tweezers here. Now this is, again, lots of layers here in this PCB, and they just want to soak away all that precious heat. And we've also got the musk goo doing its job. Okay, I'm going to stop because my solder has stopped flowing, so I need to flux it. Okay. So at this point now, I'm going to come back around the other side of the board, because this is where my problem is. Because this component is of course soldered on both sides of the PCB. There we go, look at that. First current sensor. And second current sensor. Just like that. Now, so this brings us down now to the last piece, which is our warm board multi-way header. Alright, time to remove the header. Mission accomplished. What you're going to say, folks, you're going to say, Damien, you're doing it so wrong. You are a butcher. Why did you use a blowtorch to remove the header? Well, the reason is that what I've found is that when you're desoldering a part like this, particularly where the part has been soldered on both sides, it's got a lot of thermal mass in it. If you try conventional means like a desoldering sucker, solder braid, hot air, you'll tend to get so much heat into these pins that they'll melt out of their little plastic, particularly here at this end, and you'll destroy the header basically. So although it is, yes, I agree, the wrong way to take the thing out, it's the best wrong way that I've managed to find so far. So if we could buy this, that would be fantastic, because this is really, you know, not the way I want to be doing that, but here we are. So to recap, the header and the current sensor block must be removed from the OEM logic board. The gate driver transformer, the 6 gate driver chips, and indeed the current sensors themselves may be purchased from Mouser Electronics, and I will include some links in the description to them. But current sensor block must be removed, and still, unfortunately, as I said, we did look into this, I think a few years ago. It is listed on the manufacturer's website, but it's a restricted item. So the likes of Mouser and Radionics and so on don't actually stock it. Probably because Elon buys all of them up for his own evil purposes. So, right. Now that we have our bounty of harvested components here, we're going to go ahead and bring our beta board back into play, and we're going to go ahead and get them fitted. So first things first, we're going to snap off the kind of excess material from the board that we don't need. No point having that on the bench here. I'm going to leave this on the boards if they come with it in the future, just because it's a kind of a handy protection when it's in the post. So let's get soldering basically. So we're going to kind of do this in the reverse order that we put it on. I'm going to go ahead and we'll fit the gate driver transformer. I'll fit one chip, gate driver chip, then I'll go ahead and put those on off camera. So again, little bit of flux, no need to go mad because we're using leaded solder here, so we're only just giving them a little bit of a help. We'll position our gate driver transformer on there and we'll get them soldered on. All right, so my old magnifier magnifying, Magnus magnification. Now I position my gate driver transformer. You needn't worry about orientation on this because you can't screw up if you try to put it on the wrong way around. Basically, you can see that you've got pins not matching up and so forth. So yeah, we get them where the pins match up, and every pin should have a pad basically on it. So this will apply whether you're using a harvested transformer or one that you purchase brand new. So same procedure. Yeah, we'll get one. Oh joy, we get one. No, we'll get two pads tacked on. That'll be better. Of course, I managed to, forget the fact that my that these will have a little bit of solder on them, of course, and it'll make them more likely to want to stick. There we go. Now I've got them. Alright, so I managed to actually solder two pads at the same time. Yay for me. Alright, so after that then, it's basic soldering. These are pretty easy to get to. And nothing too terrible. I would recommend doing these, fitting all these here before you fit the board to the inverter, because there's a couple tests that we're going to run on this board before we put it in the inverter. The key thing is to try and do these tests before we commit it into the inverter, because that way then if we need to test something or change something, then we're in pretty good shape to do that without having to remove it again from the inverter. Don't ask me how I know that. I've done more of these than I care to imagine. That other poor inverter that I've in the car at the minute, that's had so many logic boards in it. I have beaten the tar out of the transistors on that. Absolutely just beaten them with shorts and spikes and flipping short circuits and triggering ASC and everything else. So, alright, there's our transformer on. So I'll go ahead and I'll put a gate driver chip on here now. So if you observe on our board, you'll see that all the gate driver chips go in the same direction. And pin 1 is, as you look at the board this way, the nearest right hand pin to me. You'll see a little arrow on it. Again, apologies I can't get in here to shoot some, you know, kind of close-up Lewis style video for you. But to be honest, my soldering is not great, so it's probably just as well that I'm not using myself as an example in that sense. So I'm just going to tack down corners. Put a little bit of solder on the bit. I'm using a big, pretty thick bit here, and I'm just going to do the typical kind of a drag solder on here. You need to get a bit of fresh solder on there, because keep in mind again, if you're using the harvested ones, they will have solder on them, but it will not flow because it's leaded, or sorry, unleaded, or lead free, or whatever it is. Remember folks, lead is our friend. Lead in our petrol, lead in our roofs, lead in our solder. It's good. Lead in our pipes. We could have lead pipes. They're even more useful for using as a club as well. There we go. Yeah, I'd say even that the chips that we harvest are probably a little bit harder to fit than if you buy new ones, just because, not because there's anything wrong with them, or they're damaged or something, but it's just because of that lead-free solder being on the pins. It just does not want to flow. It says, no, bring me back to Elon. I don't want this stupid board. This board is dumb, like the people that designed it. They're all morons. I only want to serve the Elon and the Texas Instruments. I don't want to serve ST. Don't want to serve the Johannes brain. I only want to serve the Elon brain. There we go. Look at that. I swear I knew what I was doing. So, I'm going to swear I knew what I was doing another 5 times. And then we'll come back and we get some more parts into this thing. Okay, folks. So at this time, it is going to be time for a power-up test. With our 6 gate driver chips fitted, our gate driver transformer fitted. Now, this board has got 3 red LEDs. Let me get rid of the Wi-Fi for a minute and I'll explain why I had that on there, and we'll be coming back to that, so don't worry for the minute. There is a main power, or sorry, a 3.3 volt power LED here that should come on. There's a activity LED related to the microcontroller that will flash. And down here, there is a LED that if you look closely on the silk screen, it says gate fault. So what we expect to occur when we power up the board is we expect to see the red 3.3 volt LED come on, the gate fault LED come on for about 1 second, then go off at roughly the same time that the activity LED on the microcontroller begins to flash. So let's see what happens. And there we are. Let's do that again. Okay, now what does this mean? Well, it means 2 things. First thing that it means is that the microcontroller is communicating with all 6 gate driver chips, and it is configuring them and interrogating them for faults, and that they are not reporting any serious problems because that LED is not on. Now keep in mind there is a teeny tiny little glow in there, but it needs to be, to have a fault, it needs to be on, just like say this guy here. Now prior to shooting this particular segment, when I did the first power up test here, this LED stayed on. And I knew I had a problem. So what I did was, I used my little temporary connector to connect the Wi-Fi. And I looked under spot values at the gate driver status. And all 6 of my chips were reporting a receive CRC fault. So what that basically meant is that the microcontroller was getting garbage data back from all 6 chips. And kind of knowing the circuit as I do, I figured the most likely cause of that would be that I had some bad solder joints on the SPI pins, and I had a break in the SPI loop that comes out, goes through this little buffer chip, goes around here and all the way back. So there was a break in there. So what I did was I basically fluxed all the pins on this side of the chip, just ran my soldering iron along, and indeed as I was doing that I actually spotted pins that had no solder on them, and when I powered back up, got my expected result here. So there is one more check that we're going to do here. If I have my multimeter, which I do, that we're going to do now before we move on to the next part. So we're going to need some DC volts. And what I'm going to do is over here, when you see my finger, going to see some test points. And I'll give you the numbers of those test points now. As soon as I can zoom in, we've got test point 7, test point 8, and test point 6. So I'm going to place the negative of my voltmeter on to test point 7. I'm going to put the positive on test point 8. And indeed I have minus 5.1 volts. And then I'm going to put the positive onto test point 6. And I've got in or around 13 volts. I should be a little bit higher. What I find is that it depends on whether you're using the OEM transformer or the one that you can purchase. It usually results in a slight variation in the voltage. Now what that basically means is that our gate driver isolated supplies are currently running at -5 and let's say plus 13 volts, which is perfectly fine for what we're doing here. So at this point we can proceed. I'm going to proceed on to the next segment. Okay, time to get our current sensors fitted. So this will apply to whether you're using the harvested current sensors or the ones purchased from Mouser. So each current sensor chip, and I'll have to describe this to you because you're not going to be able to see it, has a little chamfer on one edge, and you'll see it yourself when you look at a data sheet or look at it in real life. Now that chamfer has to face the edge of the board, so the part of the board that's nearest me here. So what we're going to do is we're going to lift the board up, flip it over. I'm going to get my current sensor. I'm going to stick it in like that with my chamfer facing basically out towards the edge of the board. I'm going to get both of them in there. And I'm going to just stick them all the way down, okay, until they touch the board. Then going to bring them back round and go like this. Then going to get my current sensor block and I'm going to start fitting current sensor block in here. I'm going to start fitting the current sensor block in here the right way around. It'd be great, Damien. Thank you very much. Making sure that I'm got my current sensors going into their respective place. I'm going to clip that current sensor block in there like that. Next thing to do, we're going to take our small screws that we took out earlier. Now, this applies to the V3 beta board only, because I will fix this in the release board. You won't be able to fit all 3 screws, only 2. So you want to fit the center screw here. And what I tend to do with them is just get them started, couple turns, and you want to fit the one here on the right hand side. And we'll tighten those guys down. Now, so why, Damien, you say, can we not fit this screw? Does the hole not line up? Well, no, the hole lines up perfectly. The reason is that I'm a clown. I'm a clown who shouldn't be letting near PCB editing software, because I did 2 silly things. I placed some components, specifically resistor R127 and capacitor C73, too close to the hole, so they would get knocked off the board if we put that screw in there. And also I have a track that's going what should I say, a top layer track that's going way too close to the hole. So even if those components were over here somewhere, which they will be soon, if we were to tighten the screw down, there's a risk that it could damage that track. So the easiest thing to do for the beta boards is just leave that screw out. You've still got these 2, you've got the clip in the middle, and you'll have these 2 main fastener screws holding the whole thing down to the case of the inverter anyway. So it's no great problem. Now that we have our current sensor block on, what we want to do is push our actual current sensors down until they bottom out in the current sensor block. So just use your finger. Oh, he's on camera, so that won't work. Yeah, this one worked fine. he's on camera, so okay. Of course. Well, it's good in a way to experience that. So what I'm going to do is just loosen these 2 fasteners a few turns. And then, yeah, can I get this guy to behave himself in an appropriate manner? This one's fine. Oh, wait now. Well, oh yeah, there it is. There we go. There we go. So, pro tip, folks, don't tighten these guys down. Just press down on your current sensors until they're down into the block. Then you can tighten up these screws. Don't worry though, I'll edit out this bit so that I don't look like a clown. Now, yeah, we do that. We'll put a little bit of flux on here. Again, no need to go crazy because we're using leaded solder and it's a fresh board and so on. Just give a little press with your finger. Don't go crazy on that. And we will solder in our current sensors. Getting exciting. There we go. Current sensors are go. So they're in, folks. Now, you might be tempted at this stage to think, oh, okay, so now we're going to fit the header. Not yet. We've got 2 more things that we need to do here before we fit the header. And you guessed it, the next one is a boring power-up test. So let's get our boring power-up test connected. And we're going to do our permanent 12 volts and our switch 12 volts on there. Don't worry, there will be a pinout for that. It's pretty much very close to the OEM pinout. And I'm going to need my multimeter again. And we don't need Wi-Fi or any of that garbage. I'm going to power up the board. Don't have any weird current draws. We should have a little bit more current, which we do. And I'm going to ground off my meter like so. And over here there's 2 test points for IL1. I'm going to touch my meter too, and I have 1.56 volts. That's fine. And for IL2, 1.56 volts. Sweet. Okay, so that basically means that our current sensors are happy campers in their new home. So we can turn off the power again. Ping. Get rid of our test leads. Next thing that we are going to do is we're going to fit the DC-DC converter. Now again, this will be whether we're on beta or whether we're on release. This will be supplied to you. So we'll take our DC-DC. It's just a through hole part. No big deal. We'll pop them in here. And we will flip our board over. And our board will probably do something silly like that. So we need to put something under it here, just a handle of a screwdriver or something, just to keep a little bit of pressure on here. Don't need this pressure on. Don't need this pressure on. Okay, let's see. So I'm going to solder 1 pin here on our DC-DC. And we'll just lift the board up then, put my finger under it, and just press it home and melt the solder. Then we can go ahead and solder this guy in. Ooh, here we go. There we go. Then we're going to take little snips and just snip off the leads on this guy here. Ping, ping. And then, yeah, you guessed it, folks, another boring power-up test. Now you'll notice I'm doing this again and again and again here because it's, if I were to put this whole board together and power up, and let's say it was just dead, it just didn't do anything, well then I have to start, I've got a problem that I have to start at, I don't know where to look really. I've got to start on the whole thing and start isolating. But if I don't do that, if I do it bit by bit, it just makes life a lot easier. And I'm taking my Wi-Fi. I'm going to stick him in there temporarily. Go on, Mr. Wi-Fi. Go on, Mr. Wi-Fi. And I'm going to power up the board. Oh yeah, we're drawing a little bit more current now. We're up to about 300 milliamps. And I'm going to log into my Wi-Fi. There's a reason I'm doing that. It'll hopefully become obvious in a sec. And yeah, my DC voltage measurement is now working, which means that my isolated supply from the DC-DC converter is working away merrily. And let me just check my gate drivers. They're all reporting okay. So, excellent. Folks, is it finally time to fit the header? No, it's not. But it is time to prep the header. So, I'm using a little bit of desolder braid. This is the stuff that I use. I use this stuff because guess what? That works. Most other desolder braids that I've ever used in my life do not. And what we're going to be doing with this little bit of braid here is on the side that we carefully desoldered from the OEM board, I'm just going to soak up excess solder from these pins. And the reason I'm doing that is I don't want the pins to get stuck when we're trying to put them on our new sexy open inverter PCB. So I'm just cleaning off a bit of excess solder. There's not actually much on these, but it just pays to do it, I find, because we need to make sure that this guy here is an absolute dead fit into the board. So there's a few little areas here that just need to be cleaned up. Again, this is the lead-free or unleaded, for that matter, solder. So again, it really does not want to flow, but we got it. That is definitely, I think, good enough for a government job. So if we get our board now, look on the back, you'll see that the silk screen is on the back for that header. Make sure you choose the end of the header that has the short pins. The long ones are for the connector. And then we're going to go ahead and hopefully, yay! I mean, of course it fits. I'm an expert. Oh, yes, expert moron, Damien. Yeah, don't say that too loudly. Right, so there we go. We're ready to roll, ready to solder it in. Finally, you might say. Finally time. Oh, but look at me. I'm such an expert that I used my solder to hold the board flat, so now I can't solder it. This is like the Three Stooges, except there's just one stooge doing the work of Three Stooges. So does that make me a better stooge? Hopefully. Maybe I am a better stooge. So I'm just going to do the two corners. Flip the board back over, make sure, and it's not. Yeah, no, it's not flat. Now it will be. That's why we do that. And just melt your solder back. Press the header down, make sure it is flat. Because guess what, folks? If that header is not perfectly mounted on the board and you solder up all of those pins, you're going to have to go blowtorching your own board again because it won't fit. Don't ask me how I know that. Yes, I've done it. Now, solder away merrily on all 30 of these little brigands. And breathe in those weird flux fumes. Do not do that, okay? Get your fan going. Don't be like me. There we go. Are we finally finished, Damien? I hear you say, no, we're not finally finished. Not yet, but close. Now, folks, getting near. Temperature sensors. We have, guess what? 3 temperature sensors. So we have to fit them from the back. So we pop them in. They're not polarity sensitive, so suit your good selves. Push them in all the way and just bend the leads back a little bit. Not a lot, we just want enough to stop them falling out of the PCB. So I'm going to pop those leads in like that and see them coming through. I'm going to pop the sensor down. And finally, this one here. Can you see there? Can you see that? Hopefully you can see that. Hopefully you can see that. There we go. You pop them in all the way like that and just tiny bit of bend back on the leads, just like that. Okay. Now we need to get our friend that we removed from the OEM board, this guy, and we're going to go and we're going to fit him on the back of the board, hopefully. We're going to fit him on the back of the board? I hope we are. Yeah, oh, he does fit. So that's good. I think that's good. I think it's good. And I'm going to have to get my little plasticky rivet thingies now. Let me get plasticky rivet thingies out of the bag. Where's the bag? Oh, here it is. Okay. So, let's get a plasticky rivet thingy. Be great if I could find a source for these, actually. I might be able to do that. Just buy a bag of 1,000 or something. Make life a bit easier for folks, I think, possibly, than trying to ram... Oh, wow, yeah. I mean, trying to ram that back in there, that's not going to work, is it? So, we might have to go to plan B for this thing. B as in budget in there. Well, let me see if I can snip it off just enough to get in there. Can I? Be great if I could see. Well, actually I can't really. Okay, plan B. I'll stick to plan B for this for the minute. Yeah, I'm going to try and see if I can find a source for those plastic washer. No, they're not washers. They're rivets. So, okay then. Almost time. Okay, folks, so if you're anything like me, at this point, you're probably very excited and very scared at the same time. So, let's take this pretty slowly. So we're gonna, I've put that piece of board here just back on the inverter, just until I can source some of those little plastic rivet dudes. So, we'll go over here and go over our bus bars and see if we can get this guy to line up. Hopefully he just, there we go. So we're just lowering down and there it is, we're all finished. Yay, go home. Not. So, next thing we want to do is line up this little peg in the high voltage connector. And I'm keeping this end of the board up with my thumb here. And I'm pressing that down, until I get my 2 pins coming up here. And I get this locating dowel coming in here. And we should be seeing, these guys starting to pop through here. You might have to, okay, that's it, finished. Yeah, go home. Not. Don't worry, we're not going home yet. Still plenty of work to do. Now, when it comes to lining this guy up, the trick with it is to make sure that, again, that we don't press down on this until we've all our transistors coming up here through the relevant holes. Now, most of the time that I've done this, this has been actually a lot easier than you might think, which I'm probably now not going to demonstrate. Oh no, rain. Folks, I had a car open out there and of course it started to rain, so I had to run out and close it up. Let me see if I can see any. Oh yeah, there they are. Lovely. They are beginning to show signs of wanting to make friends. This dowel is lining up. This dowel is lining up. So that's all good. Now there's one of these up here that is not. This one isn't. This one doesn't want to play. So I'm going to lift the board up. Let me reseat this guy here. There he is. Reseat him. So this guy here, this pin here was a little bit bent towards that way. So I just pressed him back with my finger. And let's see now. Yeah, that's better. He's much more friendly now, and I'm seeing my transistor legs If I look down here, a little illuminated magnifier, you can see my transistor legs are beginning to just show up where they need to be. Yeah, they're good, they're good. Good, make sure there's 2 in each one. There is. Now I can just tap the board like this. Make sure I'm, oh yeah, up here on this guy. Up on the high voltage thing. Yeah, there we go. And I'm just gonna now start to tap the board down a little bit here. Just on this dowel here as well now. What am I doing here? I'm not doing so good on the low side. I'm very good here up on all the high side transistors. Got all my guys here. Yeah, 1, 2, 3, 4 coming through. I've got my HVIL on the HV connector. I've got this guy, but I'm not good here. I'm not too good here. Actually, maybe I'm okay. Now I'm just gonna hop the board a little bit there like that. So on my B phase here in this case, yeah, it looks like these guys here, 1, 2, 3 is okay on the B, but the 1 and 2 here on the B aren't playing nice. So again, we're going to lift off. Let's have a little bit. Oh yeah, they're actually bent back. So we can just press them forward with a finger. I'll even just press that third one there forward a little bit as well. And folks, another day dawns. We're right back where we started, thanks to the magic of video. I did take the opportunity just to solder in a little 5-way female header here for the Wi-Fi connection, which we will explain shortly. So let's see if I can once again make a fool of myself on international video. Now, it shouldn't be too hard. I managed to do a lot of it yesterday. You need to be good at something in your life, folks. Always remember that. Even if it is making a fool of yourself. Right. Anyway, in terms of lining up my pins, how am I doing here? Doing not too bad this time. Problem we were having yesterday was these guys down the bottom. These ones here across the top are looking good. Oh yeah. Now I need to get my dowels in. Yeah, that dowel is in. I'm going to go ahead and get this guy on because it's really just fiddly. Because otherwise the video is just going to go crazy. So bear with me. Of course, folks, as soon as I turned the camera off, the board plopped straight down on here. I did have to straighten up just a few of the transistor legs. They had kind of kinked off a little bit there. So we are looking pretty darn good. Pretty darn good. We're going to go ahead now and check. Just with my finger, I'm going to put it on the legs of the transistors. Give each one a little shake. And check that there's 2 legs up through the relevant pads on the board, because what you don't want to have happen here is to have one leg on one transistor get bent up underneath the board. That would be bad. So I'm just shaking those guys like so, and indeed we're true. Next thing is just check our 4 HV positives, they're true. I'm going to check our HVIL connection on the V3, that's not used, but we just want to make sure that it's pushed through here. So, now that we have that fun part done, I'm going to put some fasteners in here before we start doing any type of soldering. So, fasteners. So the board is naturally going to be a little bit crooked on the fasteners when you first go to put them in. So it usually helps to just straighten up the board and pick any one you can pick. I'm just picking this guy here. And what we want to do is I'm going to just give him a little bit of tension on there, and then we're going to start popping fasteners in. Now, they're not all 100% perfectly lined up. I still have a few here that aren't going to line up properly, but the main thing is that most of them will. So obviously, you know, all of these kind of things, I'm getting them closer as I'm iterating the boards. So with a bit of luck, the release board now, we'll be able to have this pretty much bang on. There's a certain amount of kind of guesswork in it. You're saying, okay, well on this board, this one looks this way out and so forth. Now, one that you will not actually be able to get in is going to be this guy here. That's hole 10, H10. That's just not going to work. So please don't kind of don't try drilling out the board, especially on these plated through pads and that, because you want to get a fastener in. What you do understand is that this is a multi-layer mixed signal board, and what we don't want to be doing is creating edges and shorts within the internal copper structure. So if a fastener, for example, just doesn't want to fit, don't put it in there. Again, this is going to apply mainly to the beta boards. And as I said, hopefully we'll have most of them lining up by the time we get to release. At least I should think so. But as I said, most of them now are pretty good. I'm just going to release this guy a little bit now that I have some of these beginning to. It's always a good idea, you know, it's a general thing to do anyway when you're putting something together, is to just start the screws before you tighten up one. This hole here on the top is looking a little bit off. Yeah, I don't want to force anything, but let me just see if I can. I mean, if we got a situation like that where you can just kind of screw the fastener in, so long as you're not drilling into the board or doing something crazy or cross-threading a fastener, you know, don't do anything like that. These two up the top, okay, are particularly important because the design of this board, and by that I mean the OEM board as well, is such that it uses the aluminium structure as part of the grounding plane system on the PCB, okay? So if you run this PCB as we were doing, for example, with some power-up tests, not fastened into the heatsink and the rest of the hardware here, certain signals on there will behave differently to what they do here when we have the board screwed in. And particularly, this one probably go in as well, particularly these 1, 2, 3 and 4 fasteners here. So the ones around the main connector and the ones around the power supply. Guessing North Carolina, somewhere around there. Sorry, I know I'm probably making a mess out of my US geography. I'm sure I'll be corrected in the comments section anyway. There we go. Again, as long as we're not drilling and as long as we're not cross-threading, that's fine. We're not going to cause any damage anywhere. But as I said, this is, you know, just primarily for the beta boards. I'm going to be spending a bit of time with this inverter, particularly now when I have it assembled and tested for the purposes of making this video. I'm going to take all these fasteners back out and I'm going to measure the holes and get as much of that straightened out as I can. So at this point, your little bag of leftover parts should have one fastener for hole 10 and one fastener here for this corner of the what's the name of this, the current sensor block. All right. Now you might be tempted at this time to get straight into soldering the transistors and so on. You can do that if you wish, and the 4 high voltage positives here. But what I prefer to do is to get the heatsink temperature sensors fitted in first. Okay, so it'll be a little bit tricky to see, but this one here on the edge is quite easy to do. You'll see there's a little raised platform with a little bit of pink heatsink compound on there. All we want to do is to get our thermistor just sitting nicely into that and then bend over the legs like so. And then we're going to solder this guy in with a bit of good old-fashioned leaded solder. Now it's a little trickier obviously for these ones, but we can pretty much do it by feel. Now you might be saying to yourself, Damien, you're doing it wrong. Why are you not using the Tesla sensors? Because they have this little this little plastic holder, tiny little PCB on there, and the sensor is up the top of it. I can show you on one of the OEM boards there. One sec, I'll snip these. Now that's a good question. You'll see them here, the little plastic thing, and the sensor is this little tip of the PCB. Now what I would like to do, I think I will do, or I might ask even one of you good folks to do, would be to redesign a little 3D printable version of that so we can put one of those off-the-shelf temperature sensors in there. The reason I don't want to remove these guys is that they're a little plastic clip-in thing here. When you try to heat them to remove them, I found that I'm just melting away the plastic and just destroying the sensor. So the way I'm seeing it is, that's a little project that perhaps someone on the forum or in the community could look at for me to design a little printable holder for those temperature sensors. But in the meanwhile, for the purposes of my own testing here, purposes of the beta, we'll just go the old-fashioned way. So I'm just pinching the wires back in and shoving the sensor down until I feel resistance, and then just spreading the wires back out. And I'm going to solder these guys in. Now at the time of making this video, which again, just to keep reminding people, is primarily aimed at the beta test, which is taking place around the end of October 2025. The microcontroller currently only reads the value from this temperature sensor here. In a future release, it will basically read all of them and take the one that's giving the highest temperature as the heatsink temperature. That's not hard to do here because we're using the 100-pin STM32. So each of these guys goes to its own analog to digital converter input. So there's no need for multiplexers and things like that. Okay. So next up, we're going to solder the 4 high voltage positive connections here. So pretty straightforward. Just get everything nice and warm. Go in there with some good old leaded solder. Now, so those are our 4 HV positives soldered in. So now we want to solder the transistors. Just at this time, folks, and at all times, be absolutely certain that you have you've your 2 pins up through the holes, depending on the variant of inverter that you're using. My ones that I have here only have 3 per high and low side of the phase, so I've always got one set that don't have a transistor coming up through them. So just keep that in mind, because the last thing that you want to be doing is have a whole bunch of these soldered in and then go to this one saying, oh, the gate pin didn't come up. Again, ask me how I know that. So I'm going to do 1 or 2 and then we'll pause the video until we have them all done. And we're going to the next fun packed stage. So just a little tip. It's straightforward through hole soldering, and there's no need to flux or do anything once you're using just ordinary leaded solder. There's no conformal coatings on the board or anything special. But there's one tip I want to give you, and that is, when you're soldering these, get the solder in, but don't linger with the soldering iron. And the reason for that is, if you keep heating this, that's a little plated through tube in the PCB. That solder is going to go, oh whee, gravity's helping me. It's going to run all the way back down the leg. And if you keep doing it, and if you take this board off and on and off and on, as I've been doing while developing this, that solder is going to build up on the transistor legs underneath the copper bus bars that we saw in there, where you cannot see it. And you're going to come along and you're going to put your PCB on there and you're going to turn it on, and that red light that we spoke about, that's going to come on. And it's going to say gate short circuit on such a particular transistor, or it'll say DSAT or some other error. And you're going to go, no, I've killed it. My beautiful Tesla inverter is dead. You will weep. You'll be sad. You'll say, I'm giving up on this stupid flipping thing. What am I even bothering doing this for? It's all a pile of nonsense, open source garbage. Then once you get over all that, you'll take this guy off and you'll do an inspection, and you realize that you need to get the solder wick out and get all of that solder blob out of there. And then the inverter is going to work again. You're going to put it in your car, press the throttle, and the wheels will spin. Then you'll even feel like a worse moron. So let me do one more here for you, just to give you an idea of the kind of time frame that I'm soldering here for now. This is one of these cartridge irons, so your mileage may differ. So I'm getting the blob on there and I'm getting the iron away. The old soldering thing, you know, that I've been harping on here about still applies. Get the heat in, do the job, get the heat away. All right, I'm going to go solder the rest of these in and we will join you in the next fun packed segment. So here's our inverter connected up. I've got it connected to my test motor here. I've got high voltage in the form of 42 volts at the minute being supplied just by a telecom's power supply. That's connected here just with some dodgy crocodile clips. The positive connection is on the right, so the nearest to this side. The negative on the left. Don't mind the color on the crocodile clips. And if we press our throttle pedal here, our motor turns away merrily. So that is the first test then of our freshly assembled board and inverter. So I'm going to switch the power supply off and we'll kind of walk you through a little bit more detail on what's going on here. So when you get ready to test your inverter, the first stage that I tend to do is I connect the resolver and the motor temperature sensor wire plug to the motor, then just connect 12 volts. And you should hear in the background, I hope you can anyway, the oil pump turning at a low speed. I'll just bring the microphone around there, so hopefully you'll be able to hear that. That's the first thing. If you're young enough, and I barely am, you might be able to hear the 8.8 kilohertz whine of the resolver exciter. And if you look on the web interface, you'll start seeing information about the oil pump, such as speed, oil pressure, oil temperature, and all that good stuff. Obviously here on the board, you should see your two LEDs, this one flashing, telling us the processor is processing, and this one telling us that our 3.3 volt power supply is turned on. You should not see the red LED here for the transistor driver having a fault. Now there is a tiny little glow on that, so one change I will be making on the BOM is to increase the value of the series resistor to that LED to prevent that from occurring. So I don't want that fooling people, say, oh, you know, I can see a little glow out of that LED, is there a fault? No, it has to be on like full force, like the one that you see here. When you are testing here, if you decide to test with the inverter removed from the drive unit, as I'm doing here, just because this is a modified drive unit, it's very important that the sequence of the bus bars is the same as when the inverter would be mounted on there, so that this, for example, top bus bar here connects to the top bus bar of the motor phase. Because if you mix those up, the motor will not run. Also, if you mix up the resolver, sine and cosine and so on, the motor will not run. Where possible, the wiring on the multi-way plug is the same as the wiring of the OEM wiring loom. So if you are using a OEM drive unit loom, you can pretty much just plug it in there with a few small modifications, which I will detail in a forthcoming episode, and also a little kind of a wiring document that I'll put together soon, hopefully. So once you get then to this point and you've your inverter punched up, apply something around 40 to 50 volts to it. That can be a power supply, it can be some series connected batteries with a limiting resistor device like a light bulb or a heating element or something like that, just for safety and pre-charging, and in case there is a fault in your inverter or something else, we want to limit any potential harm. Then we'll apply a 12 volt start pulse to the start input, assuming that you're using discrete signals like a analog throttle pedal, and you know, discrete 12 volt forward and reverse signals and so forth. If you're using CAN control from a VCU like the Zombie or something like that, that's a different kettle of fish. But pretty much what I've found is, so far, that with the parameters loaded, it's pretty much a plug and play kind of a thing, that you can just switch the inverter on, press the throttle, and the motor will spin. Just demonstrate that again here. I'll just turn on the power supply, give a 12 volt pulse on the start input, the inverter goes into run mode, it's reading the correct voltage on the bus, I press the throttle, and away we go. So that's, I guess, it. I'll stop blabbering now because this video has probably got way too long as it is. So most importantly, folks, what do you think of the new hat? Pretty neat. Okay, that's it. I'm going to cut this very exciting episode here. You've seen us go from just the bare board, well, the board as it would be received, particularly during the beta testing, all the way to having a bench test done here. The reason I use those stupid crocodile clips on there is I don't have one of the high voltage connectors that clips on the back of the inverter. Well, I have one, but it's in the car. That was very kindly gifted to me by, I think, a chap in Canada ages ago now. So I'll have to see if I can dig out one of those just for doing my own testing here a bit safer. So that's where we are at the minute. I have to do some more documentation for you folks in the shape of some wiring diagrams and pin out for that header. So I'll hopefully get that done in the next couple of days and have that available there on GitHub and probably on the forum as well by the time the beta boards reach their customers. I'll also continue testing here. I have one more board to fit of my own here on a front drive unit inverter. I won't, what's the word for it? I won't subject you to me fitting that one. It's not very much different from what you've just plodded your way through. If there is any differences in it, I'll make a little short for you. But other than that, yeah, it's great to see this coming together. And again, a big thank you to everyone involved with the project. As always, don't forget to give all this nonsense a big thumbs down. Unsubscribe, go watch some funny cat videos instead, the usual good stuff. And we will hopefully see you in the next fun-packed episode. Do check the links for GitHub and forum and so on in the video description. And in the description of this video, I will put links and part numbers for the gate driver transformer, the gate driver chips, and the Melexis Hall effect current sensor chips. So if you wish, there's no need to harvest those from your donor board. But as you can see there, there's no problem doing that if you want to save a few bucks, which is always a good thing. One last thing I do want to mention before signing off is the communicating with the inverter once you have it installed in your drive unit. The Wi-Fi module is not designed to be fitted inside the drive unit at all. That's why I have it on those little leads, just on a pin header instead of a socket that mounts on the PCB. Please, folks, do not do things like cutting lumps out of the aluminium to have the Wi-Fi module hanging around outside the drive unit, or have it stuck on the board with a bit of you know, blue tack or something like that. That's not a good plan. Yeah, so please don't go mounting those modules on the board or doing things like that. That is a mixed signal board. There's everything from, you know, little millivolt signals for current sensors up to 400 volts DC on there. So please do not do that. Okay, that's a bad plan. I will do a separate video showing you how to use the OpenInverter CAN tool, and or if you don't wish to use that, a external CAN to Wi-Fi module. This board will not support an onboard Wi-Fi, and there is no reason for it now. And one of the primary reasons for that is that once that inverter is mounted in the drive unit, you're not going to get a Wi-Fi signal through that. It's just pointless. I have one here just because I'm testing and checking and all that kind of thing, and by all means, and I will be providing a Wi-Fi module with the board and some little leads and that, so you can do what you see me doing here, both for the beta and for general release, because it's great to have that direct connection if you're troubleshooting and configuring and things like that. But you know, again, please do not mess around sticking that around the drive unit. Lastly, I didn't show it here because I'm not mounting that drive unit in an inverter, is to not forget to put the little thermal pad that you took off the OEM board back on our OpenInverter board over the active discharge resistor bank in the middle. So you'll have taken, I think I mentioned it, you'll have taken a kind of a silicon pad off this guy here. So don't forget to stick it back on your OpenInverter board before mounting it back into the drive unit. And also don't forget the gasket. Is Florida missing from here, or is that just me? I don't know. Anyway. So until next time then. Happy beta board testing.